And thank you to everyone joining us today from Europe and from all around the world. It's great being with you today to discuss advances in AI and machine learning as they're applied to subtitle and teletext creation and the distribution of content. For those in attendance unfamiliar with Digital Nirvana, we're a San Francisco-based company founded in 1996 with roughly 750 employees deployed globally. We're a knowledge management, excuse me, hold on one second, my screen went dark. We're a knowledge management software company serving the media and the entertainment community with deep expertise in speech-to-text, subtitle, caption, teletext creation, metadata generation, metadata extraction, and various forms of powerful video intelligence. Digital Nirvana is an innovator in the AI and machine learning space, delivering actionable value to content creators and media operators across the globe. Some of our marquee clients include Turner Entertainment Networks, the USTA, Discovery Communications, Warner Media, Fox News, Comcast, and Univision. For today's session, it's our goal to provide you with some real-world examples of exciting work being done leveraging the latest AI and ML technologies across the content production and media delivery landscape. In the area of content acquisition, content creation, and production, we'll be exploring a speech-to-text and captioning workflow we co-developed with a well-known entertainment news and information outlet. For this client, the most pressing requirement was the ability to turn around and deliver accurately captioned content within a very short time frame. We'll also spend some time discussing applications of AI in the content delivery space, primarily the mining of insights from within content, which allow our clients to analyze and report on product placements, perform ad classification, and uncover potential compliance issues, such as identification of explicit content. So going back to our first use case, our entertainment news client, the single biggest driver was time, or the extreme lack of time. Like many operating in the news arena, deadlines are tight and time is in short supply. Our client had a 2-hour window in which to ingest, edit, caption, and deliver its finished product to an OTT provider in the expected format. Added to this challenge was a large quantity of daily raw contribution content from the field, all of which had no metadata or context of any kind. I'm going to ask my colleague Russell to jump in and walk us through a few of the details of this client success story and how they overcame these challenges. Russell?
Thanks, Ed. In this case, while the ingestion or extraction points, the output format, all of them, there were different elements playing in all of that. But at the same time, if you look at from a technology perspective, with the single technology that was used here to accomplish this was speech-to-text, or what you call as ASR, automatic speech recognition. So what we did was we took the audio or from these footages, created a speech-to-text, word-by-word time-coded speech-to-text, and ingest this reference transcript back into the system, the PAM or MAM, and which enables search. Now, when the creative team goes in, they don't have to view the entire footage. Rather, they can put in key terms, terminologies, find relevant clips much more faster, and produce content within the timeline that was given. In this case, it was just a 2-hour window, and that's how we were applying speech to text to enable faster creation of content in this particular use case. Right?
Excellent, thank you, Russell. The secondary challenge, as I recall, for this client was the need to deliver accurately captioned content with a time frame allotted. And adding to this requirement was the need to deliver content in full compliance with the OTT provider's stringent style guidelines for captioning and subtitles. Of course, the tight timeframes mandated this work be done in-house using only internal staff, not a turnkey third-party resource. Russell, could you give us some additional color on this portion of their workflow?
Sure, Ed. So now this gets pretty interesting, okay? Here, now there are a couple of different technologies involved, machine learning applications involved in here to address this challenge. So, like you just mentioned, there is going to be reduced turnaround. So the first portion of captioning process would be creating a transcript, like we explained in the previous use case. This again is going to be transcript generation based on speech to text. And now, when the transcripts are created, the challenge is to convert them into subtitles or captions, right? In conventional methods, you just create 32 characters or 2 lines. You just give a preset split based on certain technical parameters like 32 characters per line or 2 lines or 3 lines. And now, since the platform has got platforms, if you take OTT platforms, they have got much more advanced. Look at Netflix. They have so many parameters to be addressed when it comes to grammatical, when there is a silence, how do you address, what would be the reading speed. All of that is part of new age OTT platforms or web streaming. Now, keeping that in mind, what we did was this system includes an NLP version, a natural language processor, which allows it to split captions based on not just on technical parameters like 32 characters or 2 lines or reading speed. It will also enable the system to split captions based on streaming guidelines, like Netflix or Hulu or whatever the application is. So, for example, if you want to split based on proper nouns, it will do that. It will apply grammatical. It will take punctuations into account, all based on this. So now, once you apply this natural language processor on the standard platforms, the split becomes quite efficient, whereas the captioner or the person who's subtitling doesn't need to spend much time on correcting or changing. And remember, these are all already audio synced, so you don't need to spend much time. And now this particular split or parameter based or NLP based split is what helped this customer achieve turnaround, like faster turnaround, much faster turnaround to be produced. Ed?
So Russell, while we're on the subject of accuracy, can you address the topic of speech to text and the accuracy of AI-based transcription for the creation of subtitles?
So Ed, here, like you already know, the quality of audio is the paramount picture when it comes to accuracy. In this case, we were getting around 98 to 99% accuracy because it is studio produced, post-produced content. Very clear audio. So it practically means the user only have to correct certain words, and it's all audio synced. So it just gives you the best quality in around, the best time possible.
And Russell, for this application or this use case, was there some type of confidence scoring involved with the transcript generation process, along with tools for the operators to review and edit the speech to text transcript? Could you address that portion for us?
Oh yeah. Sorry, I missed that. This, in fact, the system actually points out, like you see on my screen, the system actually points out the low confidence code or wherever the system is not confident about a particular word. So the user can go in and do corrections only for that word. You don't need to go through the whole set of words. The user can go and correct. Say, when I say 98% accuracy, that means the user might be correcting just a couple of words in the whole transcript, which again improves the efficiency.
And Russell, as I think back, there was actually a third challenge this client needed to address. And this is becoming something of a common requirement that we're seeing from many content producers and media outlets. Many operators are needing to localize subtitles and captions for delivery of content in alternate languages to alternate countries. In this use case, the need was for English and Latin American Spanish. Could you provide us some more detail on this aspect of this particular project?
You're right, Ed. We all know content has gone global for a while now, and as we see a lot more languages, whether it's dubs or subs, we see content being recreated in a lot more languages, right? So in this case, like you mentioned, there were two languages that were required. And also I'll explain two different requirements in the same application. So one was the ability to create Spanish language captions once after you create the English language caption. So here, what the application was doing is giving the user the ability to automatically create a translation from the primary language, displayed in a dual pane window, like you see on my screen, where they can view the source language video, the source language caption, and along the sidelines, automatically created translations. Now, we are using a specific set of algorithms that will determine what amount of English content needs to be considered for frame by frame Spanish translation, right? Which gives more and more accuracy. Instead of, rather than sending a whole chunk of text to the translation engines, or instead of sending line by line to the translation engines, we try to take more context based on algorithms. So that was one area that this customer was finding it, receiving a better quality localized text and go from there. The second use case was for them to import an existing English language captions and just translate it. You can just translate it just as fast as it can get. So those were the two distinct use cases in terms of localization that we were trying to address using this application. Ed.
Excellent. Yeah, thank you, Russell. So we have another segment. We may not be able to fully get to it in its entirety based on the time. We've only got a 15-minute window, and it looks as though we're already at about 12 minutes in. But for this segment, we were going to examine two different use cases from two different MVPDs. In both of these instances, operators are distributing large quantities of content between 300 and 400 channels. In both cases, each client is using compliance logging and monitoring technology to record distributed content distributed content that's been aired for common compliance reasons. Those reasons are typically to validate the presence of subtitles, to confirm audio, loudness, compliance, ad verification, quality of experience, and so forth. It's also commonly used to authenticate quality and consistency of the aired programming itself. But each of these functions really boils down to extracting data and information from the distributed content, regardless of how it originates. Leveraging high-value media intelligence by auto-generating or extracting metadata from within content was the primary challenge in each of these client success stories. Russell, can you give us some additional detail quickly on this subject?
Sure, Ed. Let me just go a little faster. Think about the possibilities that around if we can make all the video readable by machine. So that's primarily what we are doing here. Create a whole set of metadata. So in the first use case, we are creating a whole set of metadata around these video content so that the customer can identify accurate ad placement spots. Say, for example, what is an accurate spot for placing an ad which is for mobile phones, right? Or where is the spot in this whole programming? What are the spots that where they can place a car ad? So all of that, an automobile ad. So all of that being automatically identified by generating a whole set of metadata, video, whether it is face-based data, whether it is labels, whether it's objects, all of that. There is another challenge that we were trying to address, which is about brand replacement. Say, for example, you are seeing a Microsoft Surface laptop on the screen, and you want to replace it with a MacBook, right? So how do you do that? Initially, you need to identify the brand that is existing in the screen. So those were done by object recognition or logo detection or a whole series of video intelligence metadata. That's how we were addressing that.
Terrific. Russell, thank you. We had some additional content to go through, but for the sake of time and the fact that we're essentially at our 15-minute point, Carolyn, let me just at this point say thank you to you and to Mesa and to everybody in attendance today from Digital Nirvana. We're grateful to have presented this information and look forward to connecting with each of you.